According to Lambert's law of absorption, when light passes through a transparent medium, the amount absorbed by any thin layer of the material perpendicular to the direction of the light is proportional to the amount incident on that layer and to the thickness of that layer. In his underwater explorations off Bermuda, Beebe observed that at depth of 50 feet, the intensity of illumination, that is the amount of light incident on a unit area, was 10 candela over feet squared, and that at 250 feet it had fallen to 0.2 candela over feet squared. Find the formula collecting intensity with depth in this case. In solving the application problem is that we let y as the intensity in candela over feet squared and let x is equal to the depth or the distance in meter. So after we let the intensity and the depth into x and y, then we get the relationship. So it will become the change of the intensity over distance is equal to the decreasing intensity of the incident. It is decreasing because we are measuring the depth. And after that, we apply separable equation, which we will integrate both sides, and then the result will become ln y is equal to negative kx plus c. Then after that, we logarithmic function it e ln y is equal to e raised to the power of negative kx times e raised to the power of c. It will be equal to 1. So our answer is y is equal to c times e raised to the power of negative kx. Then what is asked in the problem is that we get the formula connecting the intensity with the depth. So the formula connecting the y to x is just y in terms of x is equal to as y as a function of x is equal to c times e raised to the power of negative k. So to completely solve the problem is when y is equal to 10, x is equal to 50. So substituting these values to this equation, we get 10 is equal to c e raised to the power of negative 50k. Then the other, we get the first, this will be the first equation. Then in order, because we have two unknowns, which is c and k, we need to have two equations. So for the second equation, when y is equal to 0.2 and x is equal to 250, we have this equation 0.2 is equal to c times e raised to the power of negative 250k. So this is our second equation. So solving for k in this problem, we'll have k is equal to 0.01956. After that, this will be the answer. This will be our new equation. Then, because we already find the k, we need to find for the c. Finding the c, we let again when y is equal to 10 and x is equal to 50, we have this equation. Then we can already find for the c, which is 26.5915. Then substituting this c to the equation here, we have this final equation, which is y is equal to 26.5915 e raised to the power of negative 0.01956x. So this is already our final equation, which is the formula connecting the intensity with respect to the depth. In this equation, we have At x is equal to 250, y must be equal to 0.2. So we just substitute the x in here in the equation, then we get the y, which is 0.2, which is correct. So our equation here, which is y is equal to 26.5915 times e raised to the power of negative 0.01956x, is correct.